Today we are starting a new chapter, that is wave optics, and the first topic of this chapter is Huygens principle. In Huygens principle, generally we will discuss about 5 very important points. Let us see the first point. Point number 1 is the definition of wave front. Here in this chapter you will get a term called wave front. So the first point is about wave front. What is a wave front? So it is written there in the definition that it is the locus of all the points of a medium which are vibrating in the same phase. Okay. Now let us describe the point number 1. Suppose here we have a single source of light, this one, and if light is a wave, we know that from this single point source wave will come out in every possible direction, right? Suppose if this is a point source, so from this point source light will come out in the form of waves like this in every possible direction. Now if you remember, in class 11 you got the concept of wave, and there you got not in class 11 but also in class 9 you got this concept, the concept of crest and trough. Okay, so here suppose if this is a point source, and from this point source I have considered 3 waves are coming out from it, this one and this one. Okay, apart from this 3, other waves will also be there which will be in this direction. So this is the second crest of the wave. If this is a wave, this is crest, this is trough, right? So this is the second crest of the wave. For the second wave, this is the second crest. For the third wave, this is the second crest, right? So all these 3 points will be in the same phase. Remember that all these 3 points will be in the same phase. Now according to the definition of wavefront, the locus of all the points of a medium which are vibrating in the same phase, locus means you have to join, you have to trace the path of all these 3 points. So in other word, in simple word, you have to join these 3 points, and if you do so you will get this kind of shape. This is called wave front. Now you imagine this thing in a 3-dimensional case. If the case is a 3-dimensional case, if I complete this wavefront here, we will get a circle, but in 3-dimensional case that will not be a circle, but that will be a sphere. Okay, because this point source, it is originating or it is spreading the wave in every possible direction in a 3-dimension way. Alright, so this circular wave front is actually a spherical wavefront. So I hope the definition of wavefront is clear. Okay, because here just to make the diagram simple, I gave here 3 waves, but actually there will be a number of waves in every possible direction, right? So if you join all these points which are on the same phase, you will get a sphere, and thus that sphere will be the wavefront. Okay, next point, it is given that the direction of propagation of wave is always perpendicular to the wavefront. That means just now I said that if you join this, you will get a, if you join this locus, you will get a sphere. If you take another point like this point, this point, this point, then also you will get another sphere. So in this way you will get concentric spheres, and all these concentric spheres will be the wavefront. Okay, so in the second point it is said that the direction of propagation of a wave is always perpendicular to the wavefront. Obviously it will be perpendicular. Suppose if this is the point source, and here if these circles, if these spheres are the wavefront, then and these arrows are the waves which are originating from the point source, so you can see that all these arrows are perpendicular to the wavefront, isn't it? Just a second. Okay, if this is a wave and this is the wavefront, how much angle it has made here? 90 degree, right? So in this way we can say that the waves which comes out from a certain point These waves are always perpendicular to the wavefront. Okay, that is point number 2. Then next point, number 3, types of wavefront or shapes of wavefront. So generally wavefronts are of 3 types or 3 shapes are there. See, if the source is a point source just like this, just like the source that we mentioned earlier, like this one and this one, then what type of wavefront we are getting? What is the shape of the wavefront? We got spherical wavefronts, right? So the first one will be for point source of light, it gives us spherical wavefront. The first type is spherical wavefront. Second one, if the source is at infinity, it gives us plane wavefront. Don't write in short, I have just written WF means wavefront, suppose. Okay. So in the second point, the source is at infinity, means at a far away distance. So if the source is somewhere here, we always know that for the source which is at infinity, the light rays or waves which comes out from the source, we take the light rays as parallel to each other. They are parallel rays of light, just like this, parallel rays of light. Okay, so for this parallel rays of light, the wavefront will be like this, perpendicular to the rays of light, because of this point. Direction of propagation of wave is always perpendicular to the wavefront. So here, if the light rays are parallel, if you draw a wavefront something like this, which is perpendicular to the wavefront, perpendicular to the waves, then what will be the shape? Plane. The shape will be planar, plane shape. Okay. So remember that if the light source is at infinite distance, the wavefront is a planar one, or the shape is like a plane. The last one, third one, if the light source is a linear one means it is extended source of light, like this, suppose this one, and here this is a source of light, another source, another source. So in this way it is making a linear source of light. Okay, so if it is a linear source of light, remember that if this is the, just a second, if this is the source of light, then in this direction wave will go out here, like this, this side also like this. So you have to draw a surface in such a way that this wave should be always perpendicular to the surface. So what type of surface it will be? Certainly it will be a cylindrical surface. Okay, so remember that if the source of light is linear or extended, then the wavefront will be cylindrical wavefront. Alright, here I have drawn one cylinder. In this way you can draw a number of concentric cylinders. You can draw the cylinder somewhere here, like this. Okay, you can draw the cylinder somewhere here. So you can draw a number of concentric cylinders. Alright, then point number 4 and 5, very important one. Every point on a wavefront acts as a source of secondary disturbance which emits their own wavelet, called secondary wavelets. Secondary wavelets spread in all directions with the speed of wave. Okay, so what is mentioned in point number 4? Every point of wavefront, every point on a wavefront acts as a secondary source. That means, suppose if this is a, okay, if this is a primary source, so this primary source, since it is a point source, it will, what type of wavefront will it create? Spherical wavefront. So suppose this is the spherical wavefront. Okay, this one. Now it is said that all the points, every point on a wavefront behaves like a secondary disturbance or behaves like a secondary source of light. So if this is the wavefront, on this wavefront I have considered few points. You can see here, this is a point, another. So all these points are also behaving like a source of light. What source? That will be the secondary disturbance, source of secondary disturbance, or the secondary source of light. Okay, now if this is a source of light, it will also make a wavefront, and this is a point source of light. What kind of wavefront will it make? Spherical wavefront, like this, a small wavefront. This point also will make another wavefront. This point will make another wavefront. So in that way we are getting a number of wavefronts on this surface, and these wavefronts are called secondary wavelets. Okay, and the sources which are the secondary which are here on the surface, these are called secondary source. I hope this part is clear. Okay, another point is given: secondary wavelets spread in all direction with the speed of light. Okay, this secondary wavelets, they spread all over the surface. This side also they are existing, this side also. So in with what speed they are moving? Like here we considered a wavefront. In the same way, if I consider another wavefront here, then also this secondary wavelets will be present on this. So in other words, we can just imagine that these secondary wavelets are moving from one wavefront to the other. With what speed they are moving? With the speed of the wave itself. If this is a light wave, right, and if this light wave will have a certain speed, that is 3 into 10 to the power 8 meter per second, so these wavelets are also moving with the same speed. Okay, last point, the common tangent on secondary wavelet in forward direction gives the new wavefront. Okay, suppose this is the point source. Okay, we have a wavefront. Now you are asked to draw another wavefront just next to it. What you will do? How you will draw the wavefront? The process of drawing, how we will draw it. So remember that according to point number 5, you will draw the secondary wavelets here, right? Just like this figure here. Now you have to draw one common tangent on all the secondary wavelets. So if I draw this kind of line, just a second. Okay, this is a tangent. Suppose this one, another tangent, this one, another tangent, this one. Once you join all the tangents, the thing is coming like this, just like this diagram. Okay, so once you draw all these tangents, you will get another sphere like this. This is the new position of the wavefront. This will be the new wavefront. I hope it is clear, right? One point was there, then there is one wavefront. Now you have to draw the next wavefront. How you will draw? First you will consider the secondary wavelets, then you will draw one common tangent like this, and this common tangent will give you a new wavefront. Okay, so these are the 5 points which you have to remember, especially point number 4 and 5, and with the help of these things we will, in the next video we will discuss about the law of reflection and the law of refraction. How Huygens, with the help of Huygens principle, we can prove law of reflection and law of refraction.